This is Linked Data Engineering lecture number 4, Querying RDF with SPARQL. And in this part, the last part of the lecture, I want to show you that SPARQL is more than just a query language. So you remember for sure this slide, which we have shown in the very first part of the SPARQL lecture, where you see what SPARQL is. So SPARQL, the acronym SPARQL Protocol and RDF query language, is not only a query language, it's also a protocol layer and of course the output specification of the results of a SPARQL endpoint. And first we want to look at the XML output format specification for SPARQL queries. So how does the SPARQL result look like? It's an XML file, as you see here, so therefore it's an XML document, and of course you have to use the SPARQL namespace here. And then in the header of the document, usually all the variables that are used in the SPARQL query for the SPARQL results, so the output variables, are listed. So the header contains the output variables, and the format you see here, it's simple variable, and then the name of the variable is given here. It's X, hpage, name, mbox, blurb. So it's of course all made up, but this is how it works. In the header you have the name of the variables. What else is there? After the header you have the results part, and in the results part, so all the results usually are single stated here with a binding for each of the variables. So you see here in the result set, you see here a single result line, and you see here in the result line for the variable X there comes a binding. For the variable hpage there comes a binding, and then inside this node you will find the value against which it is bound. So this then will be a single SPARQL query result. Let's have a look at the binding. In the binding itself, so you will see that, for example, here for the variable X, this is bound to a blank node which has the identifier R2. Or let's take the second one. There we have a variable hpage. It's bound to a URI, and then you see the specification of the URI. The next one, variable name, it's bound to a literal, and the literal is given in English language, so it's an untyped English language literal. The next one would be age, and this is a literal, and the data type here is integer, and then the value is 30. So these are different possibilities how variables are to be encoded in different bindings inside the SPARQL output result format. So this is quite easy. Then, of course, this format is transported over the SPARQL protocol layer. We have already heard that, but let's have a look inside that. So how does the SPARQL protocol work? So usually you use 3 parts. First one, you use the URL or URI of a SPARQL endpoint. So here, for example, it would be http example.org/SPARQL. Of course, this endpoint does not exist. It only serves as a small example. Then you specify the RDF graphs which should be queried. And this is the red one. So for example, you could here specify either a default graph or a named graph or several named graphs which are queried. And then in green comes the SPARQL query. So if you look at the colored query below there, first you specify the SPARQL endpoint, then you have the question mark, and then you specify all the graphs you are querying here in red. And of course these things should be then in the end, of course, encoded as URL. So this is URL encoding. And then comes the SPARQL query, and the separator then in the URL is here the ampersand sign. That's the black ampersand sign, and then in green comes the query equals, and then comes the entire select query also in URL encoding. So therefore you see these kind of special characters here. And this string, this URL, is transported via HTTP. So we have a simple SPARQL query, and if we look at the HTTP trace of the SPARQL query, you see here we do a GET request. Exactly here, this is an example with a SPARQL query to DBpedia. Sorry, and here the default graph DBpedia is queried, and we have a simple query. And you see here as a URL, this huge URL, including the green SPARQL query here, is asked here. And the response of the server would look something like this. So for example, if it works with HTTP 1.1, and if everything works out well, you get a 200 result or return code, which means everything is okay. And then you get some metadata about the query on that SPARQL endpoint. And then, of course, comes as a content the XML encoded file, and it's encoded exactly in the way we have talked about that. So you have a header with the variables, and then you have a result set which has all the bindings of the single result lines. This would be the trace, the HTTP trace of a SPARQL result. And of course you can try this out with the according command line tools or web-based tools where you can trace your SPARQL protocol. Okay, so this is the SPARQL protocol. We have learned that SPARQL is more than a query language, so you can do more than just SPARQL select. Of course, you could also manipulate the data inside a SPARQL or RDF store. So there is the possibility to insert new data and to update the existing data. We don't do that. This is beyond the scope of this course. But I want to show you a few more possibilities to query RDF data with SPARQL. So besides select, there is also the possibility to ask. What's the difference between select and ask? Ask checks only if there is at least one result line. So if there is one result, therefore ask only returns, no matter how you formulate the query, either true or false. So you formulate the query exactly like you formulate your select query, but instead of specifying output variables, you simply put here ask and then the from and the where clause, and if this one has any result, the result will be true, yes or no. So what we ask here, for example, in DBpedia, we want to have all the writers and we want to see, is there an author with any notable work? So we have here author type writer, author notable work, and if there is more than one answer, more result, we want to have the value yes or true. And we just try this out here on the SPARQL endpoint, and you see the result is true, which means yes, there are at least one resulting line. Okay, so this is SPARQL ASK, but there is even more. So besides ask, there is the possibility to describe resources, which means like the same way you do a select statement, you can describe all the returned resources in that select statement. So look at the query we have here. We say describe author and work, and we have the same one. Author should be a writer, and of course we want to have the connection via DBO notable work to its work, and we limit this to 10 because the result will be quite long. We will have a description of all the returned resources, which mean we return all triples which are related to exactly the resources which are specified here. Just try it out. What will be the result? The result then will not be a table. It will be RDF XML or Turtle. It depends on how you specify this. Oh, sorry, one back. How you specify this on the SPARQL endpoint. So let's try this describe query out here. I run it, and you see here the result is a Turtle file. And you see here, for example, DBR and you Elizabeth Jose. This is an author, and you see here this is of type Wikidata Q something, and it's also it has another type, and then you see here even more information about this author, that it's of type DBO agent, it's of type DBO person, and so on and so on. So you see lots of information about all these authors and also about all these notable works which are out there, and this is given in Turtle. And then you will have a Turtle file that you can process further, for example, with a program or whatever you want to. So this would be Describe. And besides Describe, there is another possibility that you can use in SPARQL, and this is Construct. With Construct, you can explicitly construct triples. How does this work? So you construct a triple here that you say construct, and then here you have curly brackets, and then you say my triple should look like there is the output variable author, then I have here, for example, an RDF property, which is here example.org has written. And then I have here the output variable work, and then this should be closed by a period. And then the rest is like in a select statement. I also select authors of type DBO writer, and I select work, which is connected to author by notable work. And then I should end up here with triples, which should be constructed exactly like this between authors and their notable works, and I limit the results to 10. So let's have a look what happens here. So you see here, this is my construct query. I type run, and you see here, again, I have here Anu Elisabeth José or José, and then you see she has written 2 works, which is this one I cannot pronounce, and the other one I can also not pronounce. Let's hear something else here. Blake Crouch has written the Wayward Pines trilogy, for example. And of course, the result here is Turtle. Therefore, also all these possibilities to abbreviate the triples in Turtle are used in the result, simply to save space in the communication. So this is Construct. With Construct, you can construct explicit RDF triples. Yeah, so besides selecting result tables, you can ask a question, and you can get, if the question has any result, you will have the result yes or no, so true or false. You can describe resources which are returned by a query and get every information that is available at the SPARQL endpoint about these resources. And you can also construct your own queries, your own RDF triples with SPARQL. So this was it about SPARQL that you should learn, and we will of course deepen this in all the exercises which are available out there. And in the next lecture of the course, you will learn how to make use of SPARQL, for example, in the setting of linked data mashups and applications. So we will try to write our own programs. We will publish linked data. We will use linked data. We will transform other data to linked data, and you will see how this will work.